Oh, hi there. It's Mr. Jennings. Thanks so much for showing up for your math learning. We're learning the remainder and the factor theorems. Particularly, we're going to be looking at the consequences of dividing polynomials by binomial factors, x minus b, and the relationship to the value of the function at that point. All right, so here are your goals. You want to be able to state, understand, and implement the remainder theorem. You want to be able to determine the remainder of a polynomial divided by another, like a binomial, and be able to do that without polynomial division necessarily. And then state the factor theorem as well. Understand the factor theorem and use it. We're going to use this to find the factors of polynomials and begin factoring higher order polynomials. Okay, using the factor theorem. Okay, so these are the things that you want to be able to do by the end of your time together with me. So let's think about some polynomial long division. Let's check their work, okay? We had x minus 2 and we wanted to divide it into this thing. Let's check their work. They do it a little differently than I did, you'll see. So they noted that we needed to multiply x plus 2 by x cubed. I'd write it over there. That's weird that it's written all the way back there. X cubed times x plus 2 is x to the 4 plus 2x cubed. And I write it this way, put it in brackets and subtract the whole thing. They changed the signs over top. Both are the same thing, you'll note. Okay. This is all rough work. So the way you do your rough work is make sure you can do it without errors. That's how you do it right. And then you check your answer when you're done. Okay, so then over here we need to multiply this by 5x squared to, when we do this minus, we get 5x cubed. So 5x squared is indeed going to give us minus 5x cubed minus 10x squared. We bring that down to get this minus 5x squared. So we need to multiply by minus 5x. And that gives us this, which they changed the signs this way, but you'll notice that my way's better. No, it's not. It's just different. I just put it in brackets and subtract the whole thing. And then we bring it down. We got this 6x here, so we need to multiply by 6. Our final remainder is 3. Their work looks good. Now let's solve p at minus 2. Okay, so just given the polynomial here, p at minus 2 is equal to minus 2 to the power 4 plus 7 times minus 2 to the power 3 plus 5 times minus 2 to the 2 minus 4 times minus 2 to the 1 plus 15 times minus 2 to the 0. And we evaluate. So this is all game for a non-calculator test, okay? Like if you don't have this level, you want to start practicing to build this level, okay? And you will like having this level. 16 plus 7 times minus 8, so it's minus 56. 5 times minus 2 squared is positive 20. Okay, minus 4 times minus 2 is positive 8, and 15 is add 15. So let's put this together in some reasonable way. I see that I can make 16 and 15 to make 31. So I've got here 31, 51, 59, minus 56. Oh my goodness, we got the remainder. Okay, so we divided by x plus 1. All right, x plus 1. So x plus 2, that's weird. Okay, x plus 2, and that would mean like that x plus 2 has this like 0 back there and minus 2, right? And when we input minus 2, not only did we get the remainder there, but we got the remainder there. Ah! So here's the remainder theorem. Copy it down, think about it, and apply it to the practice problems. You want to memorize this, but also understand this. So it's both. You need both sides of your memory and your mind working on this. If we divide a polynomial p of x by x minus b by this factor, the remainder will be the value of that function at the value b. Okay? If, on the other hand, we divide by a binomial factor with a leading coefficient that's not 1, well, we have to divide b by a, and then when we get the value of the function at that point, that will be the remainder from this division. Like if we do p of x divided by ax minus b, we're going to get some function there, but then we get a remainder that's up there that's b on a, all over ax minus b. Okay, so it's still going to show up. Right? So that's neat. So let's take a look at some examples. All right, so we want to find the remainder when we divide this by x minus 1. You could do this with polynomial long division, but we're not going to. We've got x minus b here, and so our b is equal to 1. So let's go ahead and evaluate. P at 1 is equal to 2 times 1 cubed minus 3 times 1 squared plus 8 times 1 minus 12. P at 1 is equal to minus 1 minus 13 minus 5. Yeah, I'm right. Yeah. This is indeed minus 5. Okay, so therefore, according to the remainder theorem, that was an O, theorem, comma, P, oh, that's weird, I wrote F, P at x, which is a polynomial function at x, divided by x minus 1 yields a remainder minus 5. Okay, and so that is what a solution would look like. You say it in words, what you learned by applying the remainder theorem. And when you do stuff like that, when you state things in a sentence, you are expressing your understanding. And by expressing your understanding, you make your understanding stronger. So even do this in your practice problems, then it shows up on the test. Your speed is there, your understanding is there. You're going to really like the results when you understand this stuff really well. Let's keep going. So let's find the remainder here. Oh, we're told that the remainder is 8 and that we're dividing by x minus 2. And we want to find this value k that would make that the case. So then we might say something like, there. When a polynomial f of x is divided by x minus b, the remainder is equal to f at b. Okay? Thus, colon. So now, all the algebra that follows is based on that idea. So by expressing that idea first, you understand what the heck you're doing. Okay? And your reader understands what the heck you're doing. So it's communication, and communication goes both ways. It goes into your brain and into other people's brains. And like these are communication machines up here. So do that. It's not, don't say it. Don't say, no, this is an English class. This is math class. If anyone says that, all right, there's certain things I can deal with, but for that, I just send you the vice principal. Okay, so let's go. So thus what? Algebra follows, okay? P at 2 should be equal to 8, which is equal to 3 times 2 to the 4 plus k times 2 to the 3 minus 7 times 2 minus 10. Okay, and we evaluate. 8 is equal to 3 times 2 to the 4 is 48. Don't be amazed. Okay, 2 to the 4 is 16. 16 times 3 is 48. Okay, 2 to the 3 is 8, so that's 8k. Don't write k 8. 8k, please. Okay, 7 times 2 is minus 14 minus 10. Okay, so put all of that together. You got 48 minus 24. So we have, I'll write another line for your benefit. 48 minus 24 is 24 plus 8k. Subtract 24 from both sides. Minus 16 equals 8k. divide both sides by 8. K equals -2. Okay. The question was asked in words, so answer it in words.
At the bottom. Must be the curls at the bottom.
Like that. And then spell yields right. And then you're good. Okay, so that's how those do. Okay, so let's find this one here. What is the remainder when 6x cubed was divided by x plus 4? Okay, so let's find out. Okay, so we're going to input x equals -4. So we have 6 times -4 cubed plus 23 times -4 squared minus 6 times -4 minus another 8, which is equal to, this is 6 times 64, but it's negative, so that's going to be negative. 64 times 6 is 384. 23 times 16, but that's positive, so we're going to be plus. 23 times 16, gosh, I think there's actually ways to do this with factoring that's easier. But I'm going to lose people. Okay, so 23 times 16, you can just do it in columns if you want. This is one way. So we got 8, carry a 1, 6 times this is 13, because that's 12 plus 1. And then you got 23 over here, so we've got 368 plus 368 plus 24 minus 8. Okay, 384 plus 364 gives us negative 16, and 24 minus 8 gives us plus 16. So this equals 0. Wait a minute. What does this tell us about the relationship between the polynomial and the divisor? Okay. What's therefore the relationship between x minus 4 and this? Having a think? Good. Okay, if you're still not sure, but you're having a think, that's good. That's how you learn. So let's sketch our polynomial. We are a positive cubic function. So we're positive here, leading coefficient. We're cubic, and we cross at -8. And we're interested in what's happening at -4. And we found that the remainder was 0 when it was divided by x minus 4. That means if this is p at x, p at -4 equals 0, that means this point is on the function. So we are something like, I don't know. I don't know what it is, but it's doing something like this. Maybe it's like that. Okay? But it certainly has a root there. So what does that mean? What's the relationship between the polynomial and the divisor? Okay, what that means is that means at p of x is evenly divisible by x plus 4. That means the remainder is 0, so it's evenly divisible. So we could factor this polynomial using this idea x plus 4. Okay? All right, so that leads us into factor theorem. Okay, so factor theorem states that if x minus b is a factor of the polynomial p of x, only if this is true. Why is that? Well, because if this polynomial outputs a 0, that means it's crossing the x-axis at that point. So yeah. And then ax minus b is a factor of p of x if the remainder is 0, and that would mean that p at b over a equals 0. Okay, so that would be for these ones. So that's our factor theorem. You want to be able to state that and understand its relationship with polynomials, and you'll do that by testing them. So let's take a look at these. Okay, so perhaps this evenly divides this function. We could find out by polynomial long division, but I think you'll agree that's long and cumbersome. Or maybe this one evenly divides p of x. Let's find out which. Okay, so for this one, we will test p at 3, and that would equal 3 cubed minus 3 squared minus 14 times 3 plus 24. Let's see what that gives us. 3 cubed is 27, 3 squared is 9, and 14 times 3 is 42, so we are minus 42 there. Okay, and then plus 24. If we put all this together, 27 plus 24 gives, so there it is, 51 minus 51. This is equal to 0. So yes, this one is divisible by that. It's evenly divisible. How about this one, x plus 2? Okay, well, let's try it. P at minus 2 is equal to minus 2 cubed minus 2 squared minus 14 times minus 2 plus 24. Let's evaluate. Negative 8 minus 4 plus 28 plus 24. Okay, that's way positive. That's 52, 48, 40. So this one has a remainder at that point. So yes, it's divisible by that one. No, it's not divisible by that one. You could check with polynomial long division and see. Okay, so now do some practice problems. But before you go, I have one other problem that I want to look at. Just an example. What's the remainder here? Oh, I was going to erase that so that you couldn't see my work. Okay, this would be like pretty extreme if I were to put this on a calculator, non-calculator test. But I think you should see an example and know how to do one of these examples. Okay, so we know that we are interested in f at b on a is equal to what? To find the remainder according to the remainder theorem, and we're going to get b and a from here. So this is equal to ax plus b, and we have this type of statement. So thus, and then we just do it. Okay, so let's just input. What? We can input a fraction and then do all that fraction addition and subtraction? You don't actually sound like that, but you'll look like that when you reject working with fractions. Okay, so just do it. Okay, f at minus 3 on 2 is equal to 3 times minus 3 on 2 cubed plus minus 3 on 2 minus 7. Okay, you just input and find out. Okay, so then we go, this is equal to minus 3 cubed is minus 27. Minus 27 times 3 is minus 81 on 8 because we're 2 cubed. Okay, you got to cube the numerator and denominator. Minus 3 on 2, but I'm going to multiply by 4 on 4. And the result is negative because I moved my negative out there. Kind of regret doing that. But I'm just going to scale it up so I get a common denominator 8. And then I'm going to do 7 times 8 on 8 to get my common denominator there. So then I get minus 81 minus 12 minus 56 all on 8. And that, if memory serves, works out to minus 149 on 8. That's the remainder. Okay, when we divide this function by this, according to the remainder theorem. There. So that's how, it was 2x plus 3, I think I said. 2x plus 3. Let's fix that. Of course it was. Okay, so definitely get some practice. And for practice, you're going to dive into this stuff and some delta math on factor theorem. And then I look forward to seeing you this coming week, everyone. Any questions, hit me up by email or find me in the world, in class, or somewhere. And I look forward to supporting you on your math journey. Bye for now, everybody.